In this video, we are going to look at spatial coordinates. So this is the next section moving on from from oblique planes. Okay, and what we're looking at with this is that we're looking at what are called laminar planes. Now, what laminar planes are they are sections of oblique planes. So a good example of this is if we go back a couple of pages here to this guy here, and what we basically have with laminar planes is that we have our two planes here. Okay, so these are two oblique planes, and what laminar planes is that they're basically, when we're looking at them, they're triangular most of the time. Okay, they can be other shapes. It can be various forms of shapes, and can have as many points as they want. But we're generally looking at triangles, and what we have is we're looking at triangular sections of oblique plane. So I have one here. So this triangular section here, if you imagine that being on the red oblique plane, it's just a part of it. That would be the laminar plane on that. And then what we could have then is we could have another one then on the yellow plane. So if you had another one coming along here, so if I had a second laminar plane sitting there, that would be then a laminar plane on the yellow oblique plane. Okay, and what you see then is that just like when we have two oblique planes intersecting here, those two laminar planes also have a line of intersection, and we will be looking for that as well as the dihedral angle that we would have been looking for before as well. Okay, so that's what laminar planes are. So if we go on then to have a look at how we actually go about drawing laminar planes, we will be using what's called spatial coordinates. Now, spatial coordinates, all they really are is that they are a different way of giving dimensions. Okay, and what we have with it is that you'll see here we have the vertical plane, we have the horizontal plane, we have a datum line, and then we have a point here. So you'll see here with this point P, if you look at your point P there, that point P is a certain distance up from the horizontal plane, it's a certain distance away from the vertical plane, and it's a certain distance away from the datum line. Okay, so what we get for this is we get given three dimensions for doing our spatial coordinates. We get given a distance away from the datum line. Okay, so the x dimension here. We get given the distance up from the horizontal plane, so the y dimension here. And then we get given the dimension away in the plan from the vertical plane, so the z dimension over here. Okay, so every time we're looking at spatial coordinates, we get three different dimensions, and you're going to see it over here in how the question is actually asked. Okay, so what you have here is you're given the coordinates of a laminar surface, and wants us to draw the plan and the elevation of the surface, and it gives us these coordinates. So the first coordinate, okay, is always going to be going across. The second coordinate is always going to be going up, and the third coordinate is always going to go down. Okay, that's always the way it is. And you can see here that they have that put in here as well. So it's always across to the right, up, and then down. Okay, now when it goes to putting in these points, what you just do is you, at the beginning, is that you draw in your datum line. Your datum line is just a light line. Okay, so it's not a heavy line, it's just a light line. And then everything is measured from that. So if you want to put in the 120, 48, and 12, what you'll do is you will measure across 120. So we have our 120 across first. Then you'll draw your light line down. Then you'll come up your 48. That will give you where your point is in your elevation. And then you'll come down your 12, and that will give you where your point is in your plan. Okay. Then if you were to go for another one of the points, if we were to go for the second point here, so you come across, first of all, you come across your 72, draw your light line, and then you would come up 15 for where it is in the elevation, and then you will come down 30, okay, for where it is in the plan, and you do that for each one of your points, and that's then what gives you your laminar plane once you find all of the points for that. Okay, so it's always across to the right, up and down, and just starting off with a reference line and lightly at the beginning. Okay. Now, once you have your laminar plane put in, then we're going to be asked to find the true shape. The first thing we'll be asked to do is to find the true shape of that laminar plane. Okay. And to do that, it is the same as when we were looking at the true shape of an object on an oblique plane, because that's actually what your laminar plane is. So we start off, we draw a level line. Now, what we're looking at here, this level line, so this level line is new, but if we go back and have a look at when we were looking at this at the very start, so if we go back to let's see. Okay, so this one here. Okay, so when we were looking for the true inclination of a plane, which is giving me the edge view here. Okay, what we did was we looked along the horizontal trace. Okay, so we looked for this one. We would have looked from H here. We looked up through T and then up, and that gave us the angle that we were going to draw, that we were going to project up to draw that auxiliary. Okay. Now, what's important to remember with this is that that line there, because it's a horizontal trace, that is a level line. Okay. And the reason that we use a level line for this is that what we want is we want to see it as an edge, which means we have to look straight in at it. But we want to see that line as a point, which then gives us everything else coming from that. Okay. So when we take a horizontal line and look along that horizontal line on a particular shape, because this is horizontal for that oblique plane, we'll get that as an edge. Okay. So what's useful with this is that we already have the horizontal trace, but what we're looking at here with our laminar planes, we don't actually have that horizontal trace yet, so we don't have that reference point to be able to, or that reference line to be able to actually go and to find the angle that we're going to project up at here. Okay, so what we just do then instead is we put in our own level line. Okay, now with this one, what we have for that level line is that I'm going to go up to the elevation here, because we know if we're going to draw a level line, it has to be in the elevation. Okay, because we only have a horizontal in the elevation, not in the plan. So what we do here is we go to the point that's in the middle of the laminar plane. So if you look at this, the highest is B, the lowest is C, A is in the middle. Okay, and the only reason we choose the one that's in the middle here is because when we draw the level line across, we'll get a second point over here. Okay, so we have another reference point there. What we then do is we take that, and that point in there, we project it down to the corresponding line in the plan. So in the elevation, that ended up on BC. We bring it down then to the line BC in the plan, and then join it back to A, because what we're doing here is we're just drawing that level line in the plan. Okay, so what you see there is the level line went from A across, hit the line BC, came from A here, came across and hit the line BC over here. So that's just that same green line in the two views. Okay, now that we know that that is a level line, okay, and a true length because it's level, what we're going to do, and actually that's an important point, is that this is a true length just like the horizontal trace was a true length. Okay, so this whole construction works because we're looking along a true length of a line. Okay, when we're doing it. And what happens is when we project that up, because we're looking along the true length, we get the point A, the line here, the level line here as a point in the point A. Okay, and what happens then is we take the rest of the points up and we project it, and we see the laminar plane here as an edge view. Okay, in the same way as we would have when we were looking at oblique planes before. Okay, so that's our edge view. That's how we find our edge view. So we take a level line in the elevation, bring it down to the plan. That gives us the angle then that the auxiliary is going to be drawn at, and that's always the same. Okay, so level line and then level line in the plan gives us the angle that our auxiliary is going to go at. Okay, and then the next step, which we know again before from oblique planes up until now, is that the next step would be to look perpendicular to the edge view. Okay, so here's another example of this. We have our laminar plane here given with our spatial coordinates, and we have here first of all a level line, okay, drawn the elevation, drawn from the middle one. So we have C and B are the top and the bottom, A is in the middle, so we draw that one across, brought it down to the line CB here, and you have your A looking along there. So I now have the level line and the elevation and the plan. The level line and the true length of the level line in the plan gives me the angle from my first auxiliary. So when my first auxiliary comes up, I see it as an edge view, okay, of my plane. And then to find the true shape of it, it's then just a matter of looking perpendicular to the line here. So it's perpendicular to this guy, and that's then going to give us the true shape of it down here. Okay, and just a note for understanding, that level line is going to be here. Okay, so that's the level line that's come to the other ones. You don't have to draw that, but that's just something to kind of think about when you're looking at these, because you might need it to solve a problem later on down the road. And again, just remember, if you're going to your second auxiliary, so this is your first auxiliary or second auxiliary, you always go back 2 views and do it between the first and the second. So from here, that would be back 1 view, 2 views, okay? And we want to take the distance between the view 1 and view 2. So you'll see here in this particular instance, they took a datum line here. They put it on C so that they could, and that's parallel to the X and Y1 line, so that they could just put C directly on it and then the distance for A and B there, so that this didn't end up being very far away from the X2, Y2, just to keep everything together. Okay, so level line gives us the angle for the first auxiliary. Then for the second auxiliary, we're looking perpendicular to the edge view of the plane, and that gives us then the true shape.